And I will start with our first speaker. She's Aiden, and she is a research consultant and technician at the Rice University. And she will present the development of interactive visualization for neuroscience education. And between other things, she also loves coding, cooking, music, photography, learning foreign languages, and she also raised a hamster at home. So that's her presentation, and I am glad that I just look forward to hearing the talk. So please, Eden, the floor is yours.
Thank you, Alberto. And hello, everyone. I'm Eden. Today, I'm going to present to you about the development of interactive visualization for neuroscience education. First, why do we want to make neuroscience interactive visualizations? Because in neuroscience teaching, many students are visual learners, but the concepts are very abstract, especially those high dimensionality ones. Those are the main challenges. So we get some inspirations from the Neuromatch Academy. There are many interactive widgets in Python that students can play with and stay on top of their learning. And also these visualizations make the concepts very tangible. So we aim to develop a repository of useful visualization widgets in teaching. The structure of our code is, first we develop the widgets on Godot and Unity. There are two game engines. Then we release our products to HTML forms. In the meantime, we export to computer standalone for normal test and to APK for on-screen mobile tests. Then we release them to GitHub open source. So we welcome contributions and collaborations from the community. And we are happy to have more people contribute new things. And also, we use Jupyter Notebook to hold widgets with added text and background. Teachers can embed those widgets they want to use into their own Jupyter Notebooks and add the web links to their PowerPoint to directly interact with them. At last, we use GitHub webpage to display all of our products. And next, let me show you some of our developments. The first is a head neuron in mice that change activity with head rotation. And we can adjust the camera and view it from different angles, and this is the head rotation. And the cursor on it will show the corresponding activity of the neurons. And next one, 1D Gaussian. This is mainly emphasizing the on-screen gesture development. We can use the sliders to change the two main parameters of the Gaussian. Or we can use a joystick, like those in games. Or we can just put our finger to where the peak is. And the third one is very intuitive because it goes to where the finger is and the parameters change simultaneously with the position. To the 2D Gaussian, we have two gestures. One is the rotation. We have two fingers on a mobile screen or any tablet that rotate in this way, and that we can rotate the camera and see the mesh from different angles. The other one is a two-finger drag. If we put two fingers on the screen, the code will recover an oval. The oval uses the point further away to the origin as the main axis and cross the second point. When we have the equation of this oval, we can recover the covariance of the two-dimensional Gaussian by a mathematical equation. And also, this oval represents the first standard deviation of the Gaussian contour when it's projecting to the XY plane. So the width of the oval in the x-axis and y-axis is the standard deviation of 2 dimensions. So let's see some effects. And first, the rotation. We rotate the camera by 2-finger slowly, and then the 2-finger drag to change the contour shape, so the Gaussian change correspondingly. And next is a 1-finger pen. That is a drag, which can change the center of the oval. And that is the 2 main parameters of the Gaussian. Next product is linear dynamics. And this shows how some random points in the 2D space change along the traces with steps. And it's completely controlled by a matrix, and we can play around it. And it draws some eigenvectors with the length of the eigenvalues. We find this is very similar to the ordinary differential linear system in Neuromatch Academy. So we think that we want to compensate what Neuromatch Academy has already done, not to reinvent the wheel. So this product is no longer developed. It's a first trial of the Godot software that we picked to develop those things. We have some other ideas. The first is Hopfield network. It's a binary neuron model. All the neurons can be white or black, and we click on it to flip its color. The aim is to have the connection between any 2 neurons to sum together to have a maximum connectivity strength. And this is related to the associative memory in the brain. And the second idea is we want to show some neural wiring. And the first is a game of metabolic cost. Within the cost, we want people to wire a group of neurons, and that you can't exceed that limit. And this might help people to infer the architecture of a neural circuit. And the second idea is to show some connectivity chains during a learning process. And third is to see how different inputs are passed down a network among different layers, etc. The third plan is to have a widget of place cells of mice. It's about some cells in the hippocampus of the mice that will be excited at certain places in the space. We want to show people a map and let the users move the mice around. When it arrives at a place with high excitation, it will be a circle showing, and the radius of the circle corresponds to the level of activity of place cells at that place. So I think it might explain why my hamster would like to stay in this trunk during most of his pastime. And last, I want to acknowledge that we have recently started collaborating with Aya Betty from Harvard University, who brought us interesting ideas of this waterfall animation. And this is completely developed by JavaScript. If we choose a distribution like a normal distribution and sample some points, and if we sample it 100 times, we'll see a waterfall effect. And it will automatically give us this distribution of the sampling. It's very cool. And we want to have a meeting with the developers, member to talk about it. And also, she brought us some this GitHub page to host all the projects, which saves us the effort to maintain some external servers. So we're happy to have people contribute to our open source codes. If you're interested in collaborating, contributing, or having exciting ideas, please let us know. And thank you for your attention and questions and discussions.
Thank you. Thank you very much, Eden, for your nice presentation. And is there any question from the attendees? If so, please write them. Otherwise, I have a small request for you. Maybe it would be helpful if you type in the chat after your talk the GitHub addresses and so on, so people could check out the code directly, and possibly also contributing to your effort. So we have one question, yeah, from Hire. Do you have any visualizations for neuroimaging?
What type of neuroimaging is that for? Experiments, some fMRI data, that kind of neuroimaging data?
Yeah, I think so. Kind of fMRI or this kind of data, yes.
And we can think about this because it might be some high dimensionality data that will be very interesting to develop.
Okay, thank you very much again, Eden, for your talk, and I invite our